we would like to use this video as an explanation for our customers. For us, the most important thing is to discuss the density, of course. For our clients, it's very important to know why.
First of all, it's understanding the importance of this parameter, right? Yeah. But what I can tell you, 100% of the mines, they do care about the pulp density. Yeah. What we do here actually is we're metallurgical engineers, and we sell products for grinding and flotation. So let's talk about the grinding first. I think the grinding circuit, it's the most expensive part of the mining process, because they consume a lot of energy. It's a high intensity energy environment, and also they consume a lot of steel and grinding media. So the consumption of grinding media, it's a significant part of the costs of the mineral processing plant. So what happened is, if you have the extremes, low density, you're going to be affecting the efficiency of this circuit. So in one way, and then the mill, what we have is the mill will be performing the particle size reduction. That's the only task the mill will have, is reducing particle size. And then you have a cyclone, which is the one controlling the efficiency of the mill. So the cyclone operates in a very rough condition, which is they do not take in consideration particle by particle. So they receive a lot of material, like a lot of flow of particles coming into the cyclone, and they have to make a quick decision whether this particle is okay to move forward, which is the overflow, or it's not okay, so they will move back to the mill. So that part of the process requires a specific pulp density to be effective. The cyclones, first of all, the cyclones, they have a maximum efficiency of 50%. So and the reason is 50% is, if you take if you want to cut a particle size distribution, let's say in 150 microns, the particles around 150 microns will have 50% chances of going to the overflow and going to the underflow. So a particle that has 149 microns, they have the same probability of going up or down in the hydrocyclone. So any change in pulp density will actually affect this efficiency on the cut on the particle size that we were trying to separate. So I think the combination of the circuit, when you were evaluating the grinding mill and the cyclone, the efficiency of that circuit, it's not really high. And one of the main variables affecting that process is the pulp density, right?
Yeah, yeah. And the particle size. I heard you several times about the microns of the particles. So that's also very important.
It is, but I think somehow most of the mines, they do have an accurate, or at least they target a particle size, and they pretty much control that. So it's not something that you can control, like adjusting a valve. So you set 150 microns, for example, and the plant will run around 150 microns pretty much. The consequence is how much is the cost to produce that amount of throughput and that particle size. So if you do not have this fine tune of adjustment of the process variables, the cost would be higher. So the idea is adjusting the pulp density means you're going to be producing whatever you have to produce at this minimum cost.
So as much slurry, as much small particles as possible, with the least energy consumption. So
yes, you could say that, but you know, some variables I think are mandatory in the mine side, which is throughput. They have to put the maximum throughput, and they will not cut that unless you have any circuit problems or adjustments. The second is of course, the particle size, but those two are pretty much set. So yeah, they have a plan, they have specific throughput as a target, and they have a specific particle size as a target. In the meanwhile, what we're looking at is how effective this circuit is running. So and one of the most variable, one of the most I would say variable that is actually fluctuating is the pulp density, because they do have a lot of issues with water adjustments, a lot of issues with these circulating loads that the circuit operates. So one pump they start to operate means the pulp density will be affected. If the water is constrained, sometimes they do not have water available, so this will affect the pulp density. So what I think, if you can generate enough to on the pulp density, it's an important parameter that the process management would have to access this circuit efficiency. We look to the grinding circuit as we have to optimize the energy that we have available by using all the parameters and information that we have available. Go ahead, sorry.
So it could be that it needs to be regrinded a few times to save energy cost, or?
Yes, absolutely. So this is better than going in one way. Let's say you have a particle size from like 2-3 inches, and then you have to reduce to 150 microns. Do you know, like how do you take sugar cane, the juice out of the sugar cane bar? Have you seen that process?
No,
I mean, no. Can you imagine like me twisting the sugar cane, and then you have this juice? Yeah. So when we go to these street markets and people are doing this, actually they set the machine to be very smooth on these sugar cane. So they run once, they run twice, and they run like 3 times. They take the most juice out of it. When I was a young boy, and I asked this guy, why you were doing this like 2-3 times? Why don't you do like once? And you set very tight the rollers, right? And the guy said, if I set really tight, the energy consumption would be really high, and I would have actually a low efficiency. I would not take the most juice out of the sugar cane. Yeah. So I mean, even that guy knows that, right? Yeah. So yeah. It's the same principle with the mills.
That's a good explanation of the basic principle of the grinding circuit.